Welcome to EDU World Space.
Problem 8.21. So we have some pucks moving around frictionlessly on an air table. Puck A is moving to the right with some speed that we don't know, towards B, which is initially at rest. Here are their masses. And then sometime later, they will collide. And then after that, puck A is moving to the left with a speed of 0.12 meters per second, and B is moving to the right with a speed of 0.65 meters per second. And so the two things we want to find are what was the initial speed of A, sort of the big mystery here, very interesting to know that. And then what is the change in the kinetic energy, because it will turn out that this collision is not elastic. It's partially inelastic. So let's start with part A. We know from the conservation of momentum that the initial momentum, which since A is the only thing moving, will be just the mass of A times its speed, which we would like to know. And now this is going to be equal to the sum of the momenta over here. And that is mass of A, because that has not changed, times V sub A final, which would be a negative number because it's moving to the left, plus the momentum of B, which would be M sub B, V sub B F. Now, in order to solve this, it's pretty easy. We just divide both sides by MA. And so we have the final speed of A, which recall this is going to be negative, plus the ratio of the masses times the final speed of B. And so now we just put all of these things in since we know them. Zero 0.35 kilograms, 0.25 kilograms, 0.65 meters per second. And when you put all of those numbers together, you get that its initial speed is 0.790 meters per second. Now, to find the change in the kinetic energy, all we have to do is compute the final and initial kinetic energies, because now we know how fast everything was moving in both situations. So the final kinetic energy, I'll just take this 1/2 outside of everything for the sake of saving a little bit of time. So this will be the mass of A times its final speed, which is negative, recall, but we're squaring it, so this will all be positive. Plus the mass of B times its final speed, again squared, and then minus the kinetic energy A had to begin with, and so then putting all of these numbers in, we get that the change in kinetic energy is negative, which it either has to be 0 or negative, because there's nothing going on in this problem to externally add energy to the system, and so the kinetic energy can only either be conserved, or if the deformation of the pucks is not perfectly elastic, some of it will turn into a very slight temperature rise in the pucks. And this comes out to be a fairly small number, 0.0023 joules. So some energy was lost, but not a lot. If you'd like to compute what the percentage change is, you can divide the final kinetic energy by the initial one, and that'll tell you sort of what percentage of the energy was conserved. But we don't need to worry too much about that here. You can do that yourself if you are curious. It would be a good exercise for you, perhaps. But this is the second thing we were asked to find. This was the first thing we were asked to find. So we've solved the mystery of V, and we've also determined that this was not an elastic collision.